Hey everyone, this is Jon at Cougar Creek Ranch. My call sign is November 6, November X-ray whiskey. So yeah, it's interesting. Now you can build low-cost dummy load 1 kilowatt. I paid about $34 for two 100 ohm resistors, 500 watts each. These resistors, they are not available in the past. Relatively recent they are available, and I can tell you that probably you're gonna find it much more expensive if you go to other sources. I believe AliExpress is the cheapest one. I don't get any payment from anything, so I'm just saying that based on my experience, you might find cheaper if you do your own research. But anyway, so what I planning to do is, like, I do have heatsink that I bought with that has also a fan, and that's easy and cheap. I bought it in Amazon, very cheap. You can get it there too. There are several offers, so yeah. Anyway, I want to tell you my experience. I tried to use some heatsink paste or thermal compound, but first of all, I was going to do some threads on this copper plate. I can tell you one thing: if you haven't done threads on copper, you better study a little bit before you start doing that. I broke the tool, so yeah, the copper is kind of soft, and it clogged, and yeah, it's not very easy. One recommended thing was that you're gonna do the hole with the proper drill bit and then enlarge it. So it's like for copper you have to do a larger hole, have some more space there. But I end up that I got the drill bit broken. You can see I have two of the holes, they're plugged there, that one and that one. So what I decided to do, I purchased some 138 degrees Celsius solder paste, and I'm going to try to solder this. I do have a temperature control sensor connected here, so I don't really want to go too much about that 138 degrees Celsius heating up this copper plate. And then as soon the solder paste melt, I'm going to move it immediately on top of the of this heatsink. Well, anyway, let me go and put the solder paste. Another thing I want to show you is that actually this and this terminal, I have to connect it to the ground, so I'm going to put solder paste for that too. Yeah, I don't need to go twice over the process of soldering. Okay. Well, this is the solder paste I'm planning to use, and it has a spatula and stuff like that. Yeah, I'm not going to show that action because, yeah, it's very simple. Here is what I scribe on the copper plate just with a pencil. I penciled in the area that I want to cover with the paste, so I don't think you have to be very precise about that. my understanding is that you don't have to go too thick, and yeah, I will see. It's a good chance that I'll have no problem soldering these two resistors on this copper plate. Here is the solder paste applied. I don't pretend to have it done perfectly, and I don't think it's that important if you're gonna have some solder outside of the area, right? Yeah, I'm not sure how I'm going to show you when I do the actual process, but I hope I can show something. This is my setup here. Probably will be better to use a hot plate with a more uniform temperature, but I think this is gonna make it. And I have the thermometer here, so you can see right now it's 20 degrees Celsius about here in the room. So I'm going to put the copper plate on the heat, and yeah, monitor the temperature. So it's going somewhere. Again, the solder temperature, melting temperature is 138 degrees Celsius. So I'm not going to rush with a high heat up to there. So now keep in mind that the sensor is on the side here, so the temperature of the resistor will be a little bit higher. And I would like to very much to jiggle it a little bit and make sure that the contact is done when well with the solder. So just need to get there. Again, I'm looking for 138 and not there yet, not there. Yeah, I may not be able to get the proper image when I do the adjustment on soldering, but I get I hope that you get the idea. Yeah, so it's going to about 1:30. I'm going to get closer to make sure I'm prepared to do whatever need to be done to get the things going proper. 1:37 showing. So yeah, it looks like it's melting here. Yeah, and it's melting here. Okay. Yeah, I'm going to remove it. It's still very hot, and if I'm moving around, yeah. Yeah. I think it went well, I think. Yeah. But I got to check it some more. Yeah. The temperature is still pretty high on the plate. Yeah, 126 Celsius right now. So, yes, I think that this is a success. It's not a big, complicated story here. Yeah, and that will do a good job for me, actually. Let's see. I have to wait for the temperature to go down. It's still over 100 degrees Celsius. Yeah, let me just. I think now it's not moving anymore. Anything around there? Everything is solid. Yeah, actually, I need to get it here. Yeah. Okay, now soldering the resistors to the copper plate beat any other, I guess, thermal compound solution and tightening with screws and stuff. But now the question mark is, did I manage to damage something on the resistors? So 99.8, one of them, 100.3 anyway, and the other one is 99.1. We are in business, I'll say, and again, I did think that soldering the resistors on a copper plate, it's a better solution than any thermal compound. Okay, I'm done building it, and just to show you how it's built. Actually, the two resistors, they're reaching to the center pin of the connector, and yeah, we can measure it. So see how much it is. Okay, I don't have a second hand here, so where it is? Here it is. Yes. Yeah. So this is the center, and this is the ground, and 49.6.8.9. Yeah, I guess it settled down at 49.9 ohms, which is excellent, I think. Yeah, I made it. As you can see, there are not too many parts involved here, just the two resistors that are soldered to the copper heatsink, and then the copper heatsink is also using this heatsink that is an aluminum with fins, and it has a fan. So yeah, next step will be to check the VSWR. I hope it's gonna be good enough. Okay, here is a setup. Even with a long cable like this, I can see that the VSWR is at 30.5 megahertz. Hold on a second. Is 1.04. 1.04, which is super outstanding. It's like nothing happening here. It's almost nothing. Yeah, 1.04. SWR are at 30.5 megahertz. At 250 megahertz, it's about 1.43 to 1. So the dummy load is mainly made for the HF band, so I wouldn't worry too much. 1.43 at 220 megahertz. It's still useful for VHF, at least. Excellent, excellent. Well, before I start testing, I want to bring some conclusions about this video clip. So key things here are that currently availability of 100 ohm film resistors, 500 watts, make possible to actually design a very simple dummy load for HF radios. So you can see the heatsink plus fan, it's a product commercially available. You buy it on Amazon. The copper plate is something simple you can buy from many sources. The resistors, I bought it for $34 in AliExpress. And of course, we have a standoff from DigiKey and the connector that we can buy everywhere. So very simple and very economic to build. It's gonna be somewhere around $100, the cost of the materials. A key element here that I want to mention also is to make sure that you don't have that much heat transfer toward the connector, or you don't really want to go with a plate a very high temperature. So yeah, it's better to monitor. I have actually temperature sensor on the plate, and we can see it while I'm doing the testing. Yeah, I'm sharing my bench for my two hobbies, bench rest shooting and reloading, and the ham radio stuff. I'm going to put it here, and I'm going to show you the power level that are handled by this dummy load. So CW, I am tuned in the middle of the 7 megahertz band, just for reference. And CW is putting about 600 watts. Actually, my instruments say something different. 750 milliamps plate current put about 1500 watts DC input to the power amplifier, and considering about 60% efficiency, that means it's about somewhere around 900 watts output. But yeah, I'm pretty much understanding that my Daiwa is not really very accurate, so I don't really have a good accurate power meter. Now I'm going to switch it to SSB, and I'm going to put it on PEP, okay, and see how much power it's registering there. Hello, hello, about 700 watts, but I still have more voltage that I can give it. So hello, hello, about 800 watts now, so it's okay. You can see the temperature is going up on the temperature meter here. So yeah, I'm still keeping some power, so to see the temperature raising, and now I'm going to stop. So it went up to 559 point something. Now I don't have a switch on the heatsink fan, so I don't really think it's necessary for a short test you do to measure the power. But what is important is that actually the heatsink connection is very good. The copper plate dissipates very fast, and it's a good transfer in between the aluminum heatsink that is cooled by the fan. So yep, again, a very low cost, very simple, minimal 1 kilowatt dummy load that you can build very easily with, I guess you don't need to be a mechanic or have a special qualification. Anybody can do it. Yep, try to build it if you need one. November 6, November X-ray whiskey 73, my friends.